In this video, I show you how to build this pendulum track, where a train travels from one side of the diorama to the other via a switch, finds one of two free tracks, and the other train, which had stopped on the other track, then returns along the route and essentially takes the position where the other locomotive previously stood. The whole setup has been used on this winter diorama, which you can see here, with a beautiful winter landscape, with stalls and lighting, and many small details. So, it actually started with a track plan where I laid out the C track like this. I have now laid out tracks of various lengths here. Here is a very nice wide radius and then a few shorter tracks, which I will now convert into contact tracks. This long track here, I believe it's a radius 5 that I used. We will now use it as a connection track, as not much else will happen there. You can also use two shorter tracks here to have an additional functional track here. So, in order for you to properly recognize the contact tracks, you need a feedback decoder. This here would be an S88 link, which you can connect to the CS3, for example. If you have a CS3 Plus, then the normal S88 is sufficient for you. This S88 link, it has a cable here, which you use to connect to the CS3, and it also has a connector for a power supply, as it needs a bit more power. And here we can then connect up to 16 contact tracks. This means we later connect it to the track to decide what happens when the train passes over a particular rail. So, let's connect it briefly. I'll bring the CS3 over to my side. It has a lot of connections at the back. I'll tidy it up a bit so you can see it better. And here we see the first connection, all the way on the side, is where we will now plug in our S88 link. It is plugged in with the rectangular thing facing down. And now it still needs power. It goes into the power supply here. And then you can already see on the display of the CS3, a new S88 link is shown in the lower left corner, which we could theoretically still. We can provide an update on this occasion, and that's what we're doing now. Updates are always good, so we have updated it on this occasion, and now we can theoretically rename it so we know this is our S88 link 1 if you have many. But for our diorama, we only need one. To make the feedback decoder work, we need to connect it to a ground terminal. We have a symbol for the ground terminal twice on the side, and now we simply attach a cable to it, which we then connect to the side of the setup where the 0 symbol is. Let's take the connecting track, and in the simplest case, simply use the other side of it and connect it here where it says 0. And now we can build a contact track from this one long rail. For this, we need a side cutter. So, a tool like this. And with this tool, we now cut through this track on both sides. You can see it here. I have already prepared it. Here it is already cut through on both sides here on the side. So there is indeed no longer any contact between this one shoe for the flat plug sleeve. This part is already cut on both sides on this long track. For comparison, I can show you a rail, a track, where it hasn't been cut yet. It looks like this. Here you can see, this bridge is still completely intact, and you would simply cut it open on the side here. I'll do this with my left hand so you can see it better. Here, you would simply cut it through on the side. Here at this point. So, you would cut through there. Now we can take a cable. I'll use a different color, for example blue, so that it can be distinguished better later. And this cable will now be my first contact track. And with it, I can now connect to the first port on the S88 link. I'll place it here in front. Now I'll quickly screw it in here, at number 1. It's even already open. And then I go in here and screw it back in. I'll quickly show it again on the other side so you can see it. So here. This blue cable, which is currently and securely screwed into the feedback decoder, is now simply and tightly screwed. So, now you can shorten it as much as you want. I'm going to make it a bit longer for now. You can always shorten it later. Making it longer is always a bit more complicated. And just simply connect it to the first rail, to the first track here. So, insert it with the flat plug sleeve. Now we need to strip the track on both sides, and for that, you use these small center conductor insulators, or normally center conductor insulators, but in this case, not for the center conductor, but for the side where it says 0. Then you take these small things, you have to separate them from this packaging, and then they look like this in my hand, and we now place them exactly on the outer prongs. Let's attach it to the outer spike. I hope you can see it clearly. And we do the same on the other side, but since there isn't such a shoe here, we simply take the track before it, in this case our connection track, and look at where it would arrive, and there it is also the outer one. So we simply take exactly this one on the other side and connect it over here as well. Now this side is simply completely stripped so that there is no contact here anymore, on both sides. Once on one side and once on the other, and once on the other side. That's how it should appear, in essence. And if we've done everything correctly, then, essentially, our locomotive or anything else that makes contact should already trigger here in this scenario. So, now I can take the first wagon and use it to trigger this contact track. However, to see the effect, I need to quickly go into the CS3 and program this contact track in. And that is relatively simple. We go up here into the area, pull it down, and can now simply press a plus up here. And say, what do we actually want here? Do we want to set up a new switch, a new signal, a turntable, and so on and so forth? And you almost recognized it. Below are the S88 contacts. We press on that, and now we have a contact H1 here, which we can label a bit more precisely below. For example, it says how it is connected. Is it connected directly? Is it connected to bus 1? I can quickly show you what that looks like and where the difference is. Directly connected would mean it is directly here on this link. S88 link connected down here. Up here we have 2 more buses. So, if we plug in network cables here, we can connect many such decoders in sequence. Bus 1, bus 2, bus 3, and so on and so forth. Here we see bus 1 network cable, bus 2 network cable, and here we have an older model, an older connection for the old S88 decoders, which you might still be able to buy second-hand occasionally. So, back in the CS3, we have now connected it directly. This means we press direct here, and now we can also choose on the right which of our S88 links we have. So if you have several such S88 links, they will appear here. For our diorama, having multiple would be a bit overkill, so one is sufficient here. And this is indeed our contact track number 1, so we simply call it K1. And now I just have to press start-stop in the central unit. And still nothing has happened, because my car is still literally on the connection track. If I now continue over my round track, you will see that this contact K1 lights up. So you can clearly see when I drive over it with the vehicle, it lights up. But we need something very important. We need a contact track on this side, and we need a contact track here. On this page, and on this page, so that we can later program this pendulum automation. Now, we still need a switch drive, which I just installed, because we also want the switch to be able to decide which track the train should return to. So, now let's look into the CS3 to see what we need to do here. Now, we will program an advanced event control where we let 2 locomotives shuttle back and forth. Namely, specifically, this yellow locomotive, in particular, this network maintenance train, and the small rail bus. We will simply place it on the other track, on the other side, and they should now just move back and forth. And the rail bus, of course, cannot now proceed onto this track, which is occupied by the network train. So we need to switch the turnout here so that the rail bus can move onto the free track, and we will now program this as advanced event control in the CS3. So, first of all, I created a track plan in which I included all the signals and switches, as well as the contacts we need here. For this event, although I have set up 1, 2, 3, 4, 5 contacts, I have only included the 3 contacts in the track plan that we need for this event control. Additionally, switches can already be operated, and signals can also be operated here, so everything is already working manually here. Now I need to quickly go into the system settings, and there is a section in the main menu of the CS3, if you scroll down a bit, that I have already expanded. And that is this one here, namely in Tracks, Protocols and Operation Events Extended Mode. It must be turned on for what we are about to do to work. So now we can go into the events up here and create a new event. However, for this pendulum control we have here, we do not need an event. but we need quite a few, to be exact, 1, 2, 3, 4, 5, 6, which I have already prepared. Our locomotive comes here from right to left and travels over contact track K6 via the straight switch W1, so K6 would trigger and the train arrives here. Therefore, there is an event called K6 arrival. What does this K6 arrival do? It defines that when the K6 trigger is activated, this locomotive DB netzug should slow down to 0. Additionally, signal S1 should be set to red behind the locomotive. The train should change its direction, and switch W1 should be set to round, so that the next train no longer travels over the straight switch and cuts it, but can go over it. Additionally, it should switch signal S3 to green, so that the second locomotive can proceed on its way. So, this locomotive, the DB netzug, will always arrive on this K6. It will never run on another track. That's how it's programmed here. So, we have the same setup on the other side. If the train comes from the right and moves over the round switch to K4, K4 arrival occurs. Here, it is a different train that is recorded. Here it would be the small rail bus. It also slows down to 0, switches the signal behind it to red, changes its direction, sets the switch straight for the other train, and switches the signal to green for the other train. You can easily edit which train should be used here by pressing Edit Event, then clicking on the locomotive and saying, for example, that instead of the rail bus, you want to place another locomotive on this track in the future, like this modern 290 diesel locomotive. Then I just need to update it in the other events as well. Let's do that now. So, now, the train is starting, which means we also have K4 departure and K6 departure. Let's take a look at K4 departure. Then we see here at K4, when it is triggered, the DB network train starts moving on the other track. With a small delay of 5 seconds, and then at a speed of 20%, 10%. So when the train enters here on K4, the other train is allowed to depart. The same principle applies to K6 departure. Here we see K6 is triggered. Now, on the opposite track, our rail bus is allowed to start with a delay of 5 seconds and a speed of 18%. And now we can immediately replace the rail bus here with the 290, the modern locomotive that we want to run, instead of the rail bus. Now there are 2 more events because on the right either the rail bus or the DB network train can come, or either locomotive 1 or locomotive 2, depending on which 2 locomotives you want to use for this event. So let's see what actually happens when locomotive 1 arrives. Locomotive 1 is still the rail bus for now. We will swap it out for the 290, which is supposed to arrive in the future. Now it gets a bit more complicated. Our train slows down to 0 here and switches the 2 signals on the other part of the layout to red. Now here comes a little question mark. Here the train checks whether the switch is curved or straight. In addition to this, he also verifies the status of whether contact K4 is free and contact K6 is occupied. If that is the case, these 3 conditions, then the signal turns green. Then the train also changes its direction and starts moving again at speed 3. And how this is stored can be seen when you click on the individual items. So here, this question mark W1, we define the condition here. If the switch is round, then the event should proceed. If the contact is absolutely free indeed, then the event should proceed. And if K6 is also occupied at the same time, then this event should also proceed. If that is not the case, for example, if both contacts were occupied, this event would not start at all and would therefore be aborted. And we define exactly the same thing for locomotive 1 here on the side. This also triggers at contact K2. In this case, it is the DB network train that is braked to 0. Both signals turn red. Now the switch is queried differently. Here, the switch must be straight if that is the case, and in this case, the other 2 contacts are now occupied or free. K6 is free, K4 is occupied, then the signal is switched to green and the train starts moving again in the opposite direction at a speed of 30%. Yes, and in the next videos, you will see how we turned this small diorama into a really beautiful winter landscape with many small details. Additionally, you can find the configuration file for download in the description text below this video. Feel free to subscribe and leave some comments on how you liked it.